Thank you. So when I was sitting in the audience watching all the speakers and I see the Open World Forum sign over everyone's shoulder, and I'm wondering, where is the word freedom? Where is liberty? And I think you could, next year it could be the Wolf Forum, the World Open Free Libra Forum. And wolves, it's sort of a nice metaphor. They are a very efficient, cooperative, collaborative society, a wolf pack. So next year maybe it'll be the Wolf Forum. There was a little bit of discussion earlier about foundations. SugarLabs, a project that I run, was a project before we were a foundation, and rather than establishing a foundation, we joined an existing one called the Software Freedom Conservancy. It's an umbrella organization that allows projects that want to stand on their own to be part of the umbrella. We get to worry about writing software and fixing bugs and working with our customers. They worry about all the lawyering and the business administration. So definitely check out things like the SFC, because it really helps a project grow without having to deal with a lot of the gobbledygook of the business side of things. So normally when I give a talk, I don't use OpenOffice. I love OpenOffice to an extent, but normally when I give a talk, I use TurtleArt. TurtleArt is a programming environment for children, for 8-year-olds. And so rather than just making a presentation, the children write their presentation software themselves. And so this is sort of the spirit that we take with our project. We want to make sure that the children aren't just consumers of open source technology, but they're the next generation that's going to create free software, and they're going to change the world because of it. I want to talk a little bit about One Laptop Per Child. One Laptop Per Child is a project probably a lot of you are already familiar with. It has its roots in a project that was started here in Paris 30 years ago by Jean-Jacques Servan-Schrivet and Seymour Papert. They tried to they actually invented one-to-one computing in schools 30 years ago and had one-to-one computing in schools in Senegal, Pakistan, and Colombia, all orchestrated out of Paris. Today, One Laptop Per Child, which makes this little green laptop, has put new Linux into the hands of 2 million children around the world, and that's just the beginning. Free software is critical to the mission. There's been some rumor that One Laptop Per Child ships Windows. They've never shipped Windows. Every single laptop they've ever shipped has free software, and in particular Sugar. I can't resist showing pictures of kids with the laptops. This is my favorite. It's not just that these are cute little girls from Paraguay, but what they've done is they've taken the laptop, and the laptop was deliberately designed so that the children couldn't put stickers on their laptops, but the kids figured out how to do it anyway. And so that's the spirit of the kids are going to rise to the challenge. They're going to do what they want to do, not what we tell them to do. And here's my second favorite slide of One Laptop Per Child. This is not the factory. This is the kids repairing the laptops themselves. All you need is a screwdriver. You can take the laptop down to the motherboard, put it back together again. We even put extra screws in the handle because we figured kids would lose some. So it really is a platform that is intended for the kids to own it at every level. Our goal, both with the hardware, the One Laptop Per Child hardware, and the Sugar software platform, is to raise a generation of problem solvers. Because God knows the children of this world are inheriting from us, our generation, a tremendous number of intractable problems. We're not going to solve the problems for them, but what we can do is we can raise a generation of children who know how to solve problems. They're the ones that are going to solve the world's problems, and we can help them by giving them great tools for learning. So I'm going to talk a little bit about the software now. That's SugarLabs, and that's really sort of the main theme of my talk. I'm not going to really go into details about how Sugar works. Sugar is an alternative desktop. You can run it. It's actually written in using the GNOME toolkit, but it's an alternative to the GNOME desktop or the KDE desktop or the typical Windows-like metaphor. We threw all that out because Alan Kay and the team at Xerox that invented the Windows metaphor in the 70s designed it for 1970s-style office workers. Kids aren't 1970s-style office workers, and nothing in the future has anything to do with that. So we designed an architecture and an experience that was really suited to the problems that they encounter with learning. And just a few foundational things. Learning is not collecting nouns. It's not collecting knowledge. Learning is putting knowledge to use. So learning is a verb. Learning's action. Learning's doing. And Sugar encourages kids to do, to make. And secondly, love is a better master than duty. So Sugar and SugarLabs isn't about any particular piece of content. It's about letting the children take this wonderful tool and apply it to whatever they love, apply it to whatever they're passionate about. And if they're passionate about something, they're going to do more of it. So more doing, more learning. We have a portal where there are hundreds of activities. Sugar's a platform. You plug in these different learning activities, and off you go. A lot of them actually are I would say probably about a third of the Sugar activities were written in France. There's a very big French influence here. This one is actually a series of activities from Quebec, from the University of Montreal, Jean Pichet and his students. And I like to use as an example of sort of the Sugar philosophy. This is a suite of music activities. The first one on the upper left is Tam Tam Mini. It's just a musical instrument. You click on an instrument, the keyboard becomes the instrument. You pound away, you're making music. And literally, a 2-year-old can use this. A 2-year-old can walk up and use this with no instruction. But with Sugar, we give each child a mountain to climb. We have a very low floor, easy in, but they can climb as high as they want. So they can go from just pounding on the keyboard making music to collaborating over the network with other instruments, sort of a garage band, an orchestra, to writing their own music, to designing their own instruments, to actually then peeling away and looking underneath the hood and seeing how the music software itself works. So we give each child the opportunity to dig as deep or climb as high as they want in every domain. Seymour Papert, who's the pedagogist who inspired Sugar and inspired a lot of this work, talked about the culture of learning. And what I'm going to do today is make an analogy between the culture of learning and the culture of free software. So Seymour asked 30 years ago this question, back when he was collaborating here in Paris. It's not just about learning to use the tool, but it's the culture around the tool. It's the kinds of questions you ask and engage in when you're using the tool that becomes where the learning, where the growth happens. And the analogy with free software is that free software engineers, they make things, but they also talk about the things they make. And there's a critical dialogue about everything that's happening. And that dialogue, that critique, that process of not just sharing code, but sharing the criticism of that code is where the growth and innovation comes from. And we want that same innovative process in the hands of our children. So we also encourage and give children tools to create with, but we also give them tools to collaborate with and engage in a critical dialogue. So they're in this collaborative, critical space, not just this space to make things. And so what we try to do is we try to go from the theory of free software, and Sugar's using the GPL license, and in this particular case there's a theoretical theory, a theoretical freedom that you can not just see the code, but you can modify the code. And we try to put that into practice by saying, okay, it's not just there to look at, but we've actually gone to great lengths to make the code amenable to manipulation by the end user. And because we're in France, let me make an analogy. The French used to use a television standard called CCAM. CCAM was arguably the worst television standard ever invented by man. And the reason, a woman never would have done this. The reason is because CCAM was completely unmalleable. You couldn't change it. If you wanted to do a special effect, like even something as simple as a fade-in CCAM, you had to convert your video to PAL, the British standard, make your effect, and then convert it back to CCAM. So they designed a system that was anti-end-user manipulation. And so with Sugar, a lot of free software projects, again, it's open, you can see the source code, but it's designed in a way that doesn't let the end user actually do anything. And so we've taken a very deliberate approach with Sugar. We've got a number of different technologies and a number of different aspects of the culture we're building to enable and facilitate and encourage the children to actually modify the code. And they're doing it. So this is an example, my favorite example. Last year we got a new activity, a physics application, put it out onto our Git server, distributed it from our portal, and within 24 hours, a teacher in Australia submitted a patch. So it wasn't a Sugar engineer who submitted the patch. It was a teacher in Australia within 24 hours, made a patch so that you could vary the density of the materials in the simulation. And you can see the triangle is much more dense than the square. It was only about 6 lines of Python code to do it. But nonetheless, it's an example that we've got this. We have our users engaged in the freedom of the software, not just the use of the software. This is an example, it's a little bit opaque, but this is an abacus that was invented by teachers in a little town in Paraguay. They invented a new kind of abacus, and it got built inside of Sugar. And then finally, this is a 6th grader who didn't write any code to do this, but took Sugar and distorted it in a wonderful way. You can see that his name, Benedicto, he actually made into an emoticon. And so every time his name appears anywhere in the interface, it's this 3-line, 75-character block of picture. So he's taken something that we never intended, that the engineers never intended, and really extended the expressiveness of Sugar himself. Again, a 6th grader is contributing these ideas to the project. So we have teachers doing it, we have 6th graders doing it, and we have the overall community doing it. I like to use another analogy, and that's the analogy of a kitchen. And in your kitchen, the things you use every day are on the low shelf. They're handy. You can grab this, you can grab that. The things, maybe you're going to bake a special cake at Christmas. So you need a pan. You reach way up to the high shelf at Christmas time to get that one thing you need. Well, what we're trying to do with Sugar is make programming on every child's low shelf, so that they don't think twice about grabbing the tools of free software and putting them to use to solve problems. Again, our goal is problem solvers, enabling problem solving. Those are the skills that are really going to be needed to make a difference in this world, and those are the skills that the freedom of open source software afford us. Try it. You can get it on a live USB. And again, finally, that our goal is really is that we want every child to learn and put that learning to use with tools that they understand deeply and can build themselves. And with that, I say merci and thank you.